Hello everyone, my name is Mike Dolges. I was recently hired this school year at Indiana Area School District to teach middle school technology education to grades 6 through 8. Previously, I had taught for 15 years at Admiral Perry Vocational Technical School, where I taught engineering technology. The program I used to teach at Admiral Perry incorporated CNC technology, robotics, 3D design, manufacturing, and engineering principles. We were highly successful in a STEM-based combat robotics program known as BOTS IQ. As a lifelong learner, I chose to pursue the STEM endorsement program to better my understanding of STEM education, and I hope to enhance the technology education programs at Indiana Area School District. My life outside of school is primarily focused on my family. I enjoy spending time with my wife, Michelle, and our two boys, Luke and Landon, who are 7 and 4 years old. My personal hobbies include hunting, fishing, and fast cars. And now on to how students learn science. The manner in which students learn science has changed greatly, from being primarily a traditional textbook knowledge-centered approach to more of a learner-centered inquiry approach. The discipline's concepts, theories, and models are still a focus because it is essential to gain the factual knowledge. However, students now learn how knowledge is generated, justified, and applied while actively engaging in new inquiry. Students are capable of learning science through a variety of teaching environments and delivery methods. A case can be made for each of the environments as outlined by the chapter reading. However, it is my belief that students learn best when we are able to integrate elements from each of these environments. Research suggests that preconceptions can lead to the development of conceptions that act as barriers. As teachers, we must be able to recognize these preconceptions and tailor our curricula, delivery methods, and learning environments to dispel the preconceptions. If preconceptions are not addressed directly, students often memorize content yet still use their experience-based preconceptions in real-world application. Perhaps a system of pre-assessments would aid teachers in learning the dynamics of the student preconceptions. Many students also struggle to make meta-memory connections. I believe that STEM education at an early age is extremely important to aid in deterring the development of scientific misconceptions early on. All of my junior high classes have STEM as a central theme, with an emphasis on engineering design and problem solving. The engineering problem-solving process promotes metacognitive thinking and teaches students how to learn and draw conclusions on their own experiences. In the reading, Thorndike suggests feedback is important for learning. I believe students then should be given the opportunity to build and test their ideas through experimentation and modeling. The engineering design process also provides students with the opportunity for reflective assessment and encourages students to revise and improve their thinking. Additionally, in many of my classroom activities, I include writing prompts to be completed by the students. These prompts provide the opportunity for students to self-assess and reflect on their learning. It is my perspective that STEM means coordination across disciplines. These disciplines may not be limited to only science, technology, engineering, and math, but may include the arts and reading as well as other areas. In my junior high technology education classes, I try as frequently as possible to have students solve open-ended problems in which they should draw upon their knowledge and experiences gained in other subject areas. It is my belief that student interaction and engagement will be heightened when students can use their knowledge in meaningful application. Thank you for listening to my presentation, and my favorite candy bar is a Butterfinger.